This is section 12.4, special products. So as I said in the previous video, this one's going to be kind of a shorter lecture. It basically teaches some shortcuts into multiplying some of these polynomials in certain forms. So first off, I'm going to go over example 1, which talks about using something called the FOIL method. So it says multiply using FOIL method. So you might hear people say, oh, use FOIL whenever you're multiplying two binomials. I'm going to show you what it means and explain to you why it's not inherently that important based off of what you learned in 12.3. So once this to multiply this, x minus 3 times x plus 4. We learned in the last section, as long as you take this and multiply it to both, and then take this and multiply it to both, you'll get the answer right away. So x times x is x squared plus 4x, then the negative 3x minus 12. That's what you should get when you multiply everything out. Simplify this. Our answer is x squared plus x minus 12. That's our answer for this problem. But using the FOIL method, it's inherently the same exact thing we went over last time. FOIL basically stands like for this. The F stands for front. The O stands for outer. And then the I stands for inner. And the L stands for last. So what it means is FOIL means multiply the front, F, and then the outer numbers, outer, then the inner numbers, and then the last numbers. What are these green? Then the last numbers. That's essentially what it is. Saying for the first one, the F in purple, do x times x, which makes x squared. Then do O, which is x times 4. Then I, which is negative 3 times x. And then L, which is negative 3 times 4, negative 12. We multiply it out and simplify it. We get the same exact answer. What I want you to notice really quick is notice this is what we got on the previous problem with our old method. This is what we got with the new method, the FOIL method. I inherently don't like FOIL, quote unquote, method because when I went in high school, I did this and it actually confused me even more. Factoring was one of the biggest things I struggled with, factoring and multiplying these binomials because it's confused. It's like, I don't get FOIL method. They basically took something that was complex and made it even more complicated for me by making a shortcut or something. So I never really understood FOIL method. It just didn't really click with me because this is what I had to look at. I had to look at all the little shortcuts and everything. I was like, oh my goodness, there's got to be an easier way, just a simpler way. So what I like to do, like the last section I showed y'all, is to simply just multiply how I showed you. If you multiply the way I showed you in 12.3, you're going to be fine with everything math throws at you when it comes to multiplying polynomials. Don't necessarily worry about FOIL method. I don't really like it per se. So in this instance, we say 2x times x makes 2x squared. 2x times 4 is 8x. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. And that gives me my answer right away. I don't need to think about front, outer, inner, last. I don't know. That just confuses me even more. Just distribute the first term to everything, the second term to everything. That's all FOIL is. So when your homework asks about you doing FOIL method, don't worry about it. You don't have to use FOIL method. The homework's not going to know if you use FOIL method, like this method, or if you use this method. It won't know. It doesn't have any way to determine that. All you have to do is do the problem. As long as you get it right, you get it right. So when it says do FOIL method, you can choose to use FOIL method, but you don't have to. I will not test you on using FOIL method. Even if this is an in-person class, I wouldn't test you on a FOIL method. I never do. It's just a little trick that helps you multiply these polynomials. And the problem with FOIL method is that it's only restricted to a binomial times a binomial, meaning if I had something like x squared minus 2x plus 4 times x minus 2. I can't do FOIL anymore because there is a front, there is an outer, but there's no like inner. This is like the inner, and this is like the last. It just gets confusing. So FOIL method is very limited. I don't think it's really that useful. It's supposed to help you understand things, but I think it makes it more confusing. So we're going to go into next is some of the special products, like binomial products. Let's look at example 5, or let me illustrate what the binomial is first. So here's some of our special products. We have a plus b squared. This is a formula. This makes a squared plus 2ab plus b squared. And if I have a minus b squared, that would make a squared minus 2ab plus b squared. I'm going to explain this in a sec, how to use it. Let's learn by example. So these are some of the special product rules. Let's do example 5. So for a, it's saying to do t plus 2 squared. Let's multiply this out with our old method that we did. So what we did is we did t plus 2 and we expanded it to t plus 2 times t plus 2. We then took the first term, distributed it to the first and the second. That would give us t squared plus 2t. And then we distribute it to the second. See, like this old method will work for all of your problems. You don't need to do any of these shortcuts I'm about to show you. This makes t squared plus 4t plus 4. Get your answer, right? Well, let's look at the special products method. Let's go ahead and take that t plus 2 squared. Wow, that was pretty hideous. Okay, there we go. T plus 2 squared. We're going to multiply it using this special product. So let's look at what we're given. We have t plus. So it's a plus b squared. That's essentially our format. So you can see that this right here, it's an a plus b squared format. So what we can do is do a shortcut. We can follow this. Essentially it says take our a, which in this case would be t, and square it. And we're going to say plus 2ab. So this is our a, this is our b. Our a is t. We're going to follow the formula, put a t here. And this would be 2 times t times 2 plus 2 squared. We follow our little formula that we have up here, and it helps us multiply everything out, and we get our answer right away. Now, the formula, to me, it's a little confusing. So this is a way like I kind of envision doing it when I'm doing it mentally. It's still following the formula, but it's kind of a easier way to do it. All right. So for one thing, I didn't mention in the other section, but remember like if you had something like this, if we have 3x squared and we distribute that squared to both, that would then give us 9x squared. But if you have 3 plus x squared, you cannot do this. It does not equal 3 squared plus x squared. You cannot do that. So this would be wrong. Wrong. You can't do that. Remember, if it's 3 plus x squared, you've got to expand it to make it 3 plus x times 3 plus x, and then that would give you 9 plus 3x plus 3x plus x squared, and that gives you 9 plus 6x plus x squared as your answer. Notice how different this is than what this would have been. They're different. So you cannot distribute a square to these two because of this addition sign right there. You can only distribute if everything on the inside is multiplying like that. So if I had something like 2x squared, y squared, z squared, all to the third power, yep, I can distribute 3 to everything. However, if I have 2x squared, y squared, and then I throw in a plus or a minus, I can't distribute. I'm going to have to use the long multiplication method. So I cannot do this number. You cannot distribute those, all because there's a plus sign right there. You can only do this distribution thing whenever there's no plus or minus sign on the inside. So with that said, what I do for this problem right here is I'll temporarily use that rule to kind of this idea of what you shouldn't do to help me solve this one even quicker. So what I do is I'll say x squared makes x squared. Then this middle number, the next number, is going to be this number times this number times 2. So I'm saying x times 3, and then we're going to say times 2. You're always going to put this 2 on the outside. X times 3 times 2 makes 6x. Then I'm going to say 3 squared. That would give me 9. And I get my answer right away. Let's try another one. Y plus 5 squared. So what I do is I say y squared plus y times 5 times 2. I do this number times 2. We always put a 2 there. That gives us 10y, then 5 squared, which is 25. I get it right away. Go ahead and do another one. Let's say m minus 6 squared. So m squared. And then now we're going to put a minus because this is a minus. It'd be minus this number. I'll put it in the color. This times 2. So m times negative 6 times 2. That makes negative 12m. And then this number squared. Negative 6 squared makes positive 36. So you get a lot of these answers right away. It's a special product rule. Let's say I have, this is another example on it, p minus q squared. Again, take this times that, or exponent. That gives us p squared. Now do this times 2. P times negative q times 2. That would give us negative 2pq. Then take this number squared. That would be plus q squared. It's kind of a shortcut from expanding it. Let's do like x plus y squared. This time, this raised to that power is x squared. Multiply these two, then times 2 would be 2xy. Then say that, raised to that power. Makes it a lot easier. I'm not actually foiling these in my mind. I'm not doing this. I'm not multiplying them in my mind. You can do this method still. You'll still get the correct answer. But with these binomial squareds, you can do this little shortcut method. Let's try 2x minus 3y. It's a little trickier, squared. I'm going to have to do this entire quantity squared. So if I do the entire quantity squared, that's actually going to give me 4x squared. Then we're going to do this times 2. 2x times negative 3y times 2. That gives us negative 6x, oops, not negative 6, I done messed up, negative 12. Negative 12xy. Then take this entire thing squared. That makes positive 9y squared. And let's go back to a simpler problem again. X plus 1 squared. This squared. is x squared. This times 2 would make 2x. Then this square would make 1. Once you get the hang of it, it becomes a little easier to get it down. I'll do one last one. Let's say xy minus 2xy. I'll say, actually, no, I'll remove one of the y's. I'll just say 2x squared. So we have to say this entire thing squared. This makes x squared y squared. Then this times 2. So right down here, xy times negative 2x times 2. That gives us minus 4x squared y. And then the last one, we're going to go ahead and do this entire thing, well, with the negative sign, squared. And that gives us plus 4x squared. So we can simplify these binomials quicker using that method. And that would be the sum and difference, or the binomial squareds. It helps us solve some of these multiplication problems a little faster. So one last one that we have is this one. A plus b times a minus b equals a squared minus b squared. This is a special product you'll see a lot in your next class when you're going into factoring. So it's saying multiplying the sum and difference of two terms. Essentially, let's say I have x minus 2 times x plus 2. Notice this is a and b, this is a and b. Essentially, this term and this term are the same, and this term and this term are the same. The only difference, is there's a minus and a plus sign between them. So everything's the same except there's a minus and a plus. Well, let's check our FOIL method, or the multiplication method. Multiply those two, that makes x squared. That makes 2x, negative 2x, minus 4. These two cancel out because they're opposites, and we're just left with x squared minus 4. So this binomial, not binomial squared, the sum and difference of two terms makes it a little easier to solve. As long as I notice this and this term are the same for both of them, and one has a minus, one has a plus, I can just assume the answer will be the first term squared, then the second term squared. So x squared, and then negative 2 squared, or minus 2 would be minus 4. And you're just going to square that term right there. Let's say I have y plus 5, y minus 5. This was simplified to y squared minus 25. This term right here, this will always be a negative for all these problems as long as it's in this form. If I have, say, z plus 7, z minus 7, that would end up being z squared minus 49. If I have x plus 1, x minus 1, the first term squared is x squared, second term squared, 1 squared is 1. Let me do a different one that has a few more terms in it. Let's say 2x minus y times 2x plus y. Again, these are the same, these are the same. The only difference is there's a minus and a plus sign. So this entire thing squared would be 4x squared. This square would be y squared. If I have 3x minus 4y, 3x plus 4y. Again, these are the same, and these are the same. Just a minus and a plus. First term squared would be 9x squared. Second term squared would be minus 16y squared. And you keep doing this as long as you have two monomials multiplying like that. I can even make something a bit more complex, like 3xy minus 4y times 3xy plus 4y. As long as this and this are the same, and this and this are the same, the first one squared would make 9x squared y squared. Second one squared would make 9 minus 16y squared. So all in all, for this section, this is really a bonus section. Whatever you do in the section, you don't have to do a lot of the shortcuts. So again, going back to x plus 2 squared, the shortcut would make it x squared plus 4x plus 4. But if you want to do the long way, that's completely fine. You get the answer the same exact way. It just takes a couple of extra steps. It's not even that many extra steps. So I'm not going to test you over any of these special products. If you have x minus 3, or we'll say x plus 3, x minus 3, by our shortcut method, this would become x squared minus 9. But if you want to use the long method and distribute x squared, that'd be x squared minus 3x plus 3x minus 9. And these cross out. By all means, go ahead and do that. You can do one or the other. It doesn't really matter which way you do it. You'll get the same answer the same exact way. So you can use your old school methods if you'd like, totally fine. Or you can use some of these new methods to make it a little quicker. It's really a matter of preference. You don't have to use special products. You will be using this to this in your next class for the next semester. You will be factoring from this to this. And that's important to kind of get the hang of that one. All right, well, that is section 12.4. Again, pretty short section, just a couple of shortcuts. If you want, you can do the 12.4 section just like you would for the 12.3 section. You do not have to use any of the shortcuts. It's not required. You can answer everything just like you did on 12.3 if you feel. We'll go into section 12.5, which will talk about negative exponents.